just as people filter in, thought I'd go ahead and kind of introduce myself. My name is Dave Killgore. I am a CPI, like AJ said. I am also a full-time inspector with my local AHJ, authority having jurisdiction. So I currently work as an elevator and electrical inspector. I also still occasionally go out and do some building inspections, things like that. I am also the owner of Killgore Instruction and Education. It's just a way for me to help educate people on codes, and I go over specifically building codes and electrical codes and electrical and elevator codes with various companies. Excuse me. I specialize in the initial instruction and continuing education of construction and building codes, basically. I'm a true believer in having as much information as possible when going out and doing inspections, whether that's in my day job as a building inspector, or going out doing home inspections, things of that nature. I'm a true believer in the more we know, the better we are, right? And my goal for today really is to kind of help help you as a group understand what goes on behind the scenes as an inspection department that works for an AHJ when it comes to solar installations. Because as we've seen over the last several years, solar, in our jurisdiction, we would do 8 or 10 a year. We're now doing 8 to 10 a day. So it's just exploding. It's getting crazy how many people are having solar panels installed on their roofs. And if you're inspecting those houses that have an existing solar installation on them, and you're in a jurisdiction that doesn't have inspections on them, it's going to be totally different than what you would find here in our jurisdiction. So I'm gonna go through the process of what the installers have to go through before they're even allowed to install a single piece of equipment on a roof here in our jurisdiction. So a little more information about me. My background is electrical. Been a master electrician. Started in the trade in 1988. Got my journeyman's certificate in 93. Got my master's license in 95. I was an electrical contractor for several years. Closed up shop and became an inspector because I felt the need to help my local community and make sure that everyone's doing things the same way and doing things safely, right? I am a CPI with InterNACHI, and I'm also a residential combination inspector with International Code Council, ICC. That's who certifies building inspectors around the country. Basically what that means is I have certifications in electrical, building, HVAC, and plumbing. So I'm certified to inspect all of those things. As we go through this today, if you have questions, feel free to throw them in the chat. If I see something that it's kind of pertinent to what we're talking about, I may try to address it then. If not, I might just go through the questions, go through the chat at the end of the presentation, and we'll see where we go from there. There is a question that someone asked where my local AHJ is located. I am in Wichita, Kansas. So I'm smack dab in the middle of the country. Solar in and of itself where I am, out in the outer edges, California, they've had it forever. We have really just got hit with it over the last couple of years. Like I say, we used to do 8 to 10 a year. And in the last year, it has just jumped exponentially. With that, we have solar installers just crawling out of the woodwork from all over the country. And what we have found is that there seems to be a lot of installers who have never truly seen what the codes are that they're supposed to be following. They don't they're just going by, okay, here's our equipment, this is how it goes on the roof, this is how stuff goes on the wall, we install it and we walk away, and there's nobody coming in behind them to make sure it's code compliant, not just safe but also code compliant, because the codes are here to make everybody safer. All right, so solar power is becoming a force across the country right now. Solar companies, they're blanketing the country. They're blanketing entire communities. So what we're seeing here is they're going, they'll pick a part of our city here, and they will just blanket that area, and all of a sudden we'll have 30 solar installations in a 30 block radius, which is a lot. So chances are, if you're not seeing a lot of houses right now with solar panels on them, more than likely you're going to see them coming a lot more in the future. Obviously, the things that we're seeing today come into play. We typically aren't going to see it as home inspectors until later on. So today I'm going to take a little time to discuss the installation of solar panels on private residence roofs and what we, the AHJ, requires of the installation contractor. We're going to talk about what we as home inspectors should keep an eye out for through this process, and that'll help make our customers feel a little more comfortable that they're buying a home with a safe solar installation on it. So in the beginning process, before an solar installer can even deliver materials to a house, they've got to submit some paperwork to us. So that paperwork, we have to go over as inspectors to make sure that what they're going to install is it meets all of the applicable codes, whether it's the National Electrical Code or the International Residential Code or our local amendments. Now, locally, we don't adopt any specific solar codes. We just go off of those, the residential code, the building code, and the electrical code. So some of the requirements that we have for solar installation paperwork, we have a checklist that they have to fill out. They have to apply for a residential building permit, because the installation of the solar panels, it changes, it alters the engineering of the roof. Essentially, we've got to make sure that roof can handle the load based on wind and snow and all of those things that go along with that. They have a specific PV or solar application they have to fill out, and they have to submit a complete set of plans, as well as a structural analysis that has to be signed by, in our jurisdiction, a Kansas engineer, a Kansas professional engineer. If they deliver a set of plans that's stamped by someone in Pennsylvania, we will not accept that. We require it to be stamped by an engineer in Kansas that's licensed here. And what they have to say in that they have to present a letter stating that the roof can support the added load of the rails, the electrical, the solar panels, and I'll go a little more in depth in those documents. So the job of the inspector at this point is to be a plans reviewer. As an inspector, we've got to determine that the installation proposed is code compliant, and the reviewer must understand all of the solar components, how they relate to each other, all codes that apply to the system, whether it's the NEC, the IRC, or the IBC, so the National Electrical Code, International Residential Code, or International Building Code. Again, we don't adopt any specific solar codes at this time. And we also have to know how to thoroughly read and interpret a set of plans and one-line documents. So I'm going to go ahead and pull up so I hope you can see that on your screen there. This is our checklist that we make them fill out. So they have to have, this is for the expedited permitting process. It's got to have a site plan showing the location of major components of solar system and other equipment on the roof or legal accessory structure. So if they're going to put that solar system on a detached garage or a shed or anything of that nature, that has to be a part of this. The plan's got to represent the relative location of components at the site, including but not limited to the location of the array, the existing electrical service location, the utility meter, where the inverter is going to be, the system orientation and tilt angle, and the plan should show access and pathways that are compliant to local codes. They've got to give us a code sheet representing current adopted local codes, a one-line electrical diagram, engineered stamp by a state registered professional engineer, specification sheets for all manufactured components. And on those specification sheets, we require everything to be UL listed. There's a lot of solar panels that are being installed out there that are not UL listed, so that's something to keep a lookout for. All diagrams and plans include the following. Got to include the project address, section, block, and lot number of the property. So they have to go in and they actually have to provide the legal description of the property they're putting the solar on. The owner's name, address, and phone number, the name of the address and phone number of the person who's preparing the plans, and the total valuation of the project. Now, we required that because in our jurisdiction, all permits, all building permits are based on the valuation of the project. So here's the checklist. So does the solar installation have a rated capacity of 30 kW or less? The solar installation is not subject to review by architectural historical review. So if it's going on a historic home, something that's on the historic registry, that could be a problem. The solar installation does not need zoning variance or special use permit, conditional use permit. If the zoning of the area does not allow for the solar installation, that could be a problem. So the solar installation is to be mounted on a permitted roof structure of a building, on a legal structure or ground mount on residential property. It's compliant with all applicable electrical and building codes. That's a big one for us because a lot of them that come into town aren't initially. The installation is compliant with all local fire codes. The solar installation contractor complies with all licensing and other requirements of our our department, MABCD. The proposed equipment is permitted by code, and equipment meets all relevant certification standards. The electric system and all components will be installed per the manufacturer's specifications. The project will comply with the latest adopted National Electrical Code requirements. The roof has no more than just a single layer of roof covering in addition to the solar equipment. That's a big one there. If there's multiple layers of shingles on there, the chances that that solar array is going to come loose from the roof is pretty high. The system is to be mounted parallel to the roof surface or tilted with no more than an 18-inch gap between the module frame and the roof structure. System will have a distributed weight of less than 5 pounds per square foot and less than 45 pounds per square foot per attachment point to the roof. So if any of those questions are no, then their application process stalls at that point, and it creates more work for everybody, because then some more research has to be done. So I'm going to get into the PV application itself. So here what we require: the property owner's information. Is it going on a 1 or 2 family structure, a townhouse, commercial, or other? If it's going on a commercial property or an agricultural property or some industrial property, a lot more hoops have to be jumped through. They've got to provide the total system capacity rating, which is the sum of all the panels, every panel that they have on it, everything that it adds up to. The contractor's information, what the existing roof material is, what type of weatherproofing they plan on using to seal the holes when they put the lag bolts through the roof. And is the mounting structure an engineered product designed to mount solar electric modules to? We got to have this mounting system manufacturer, the product name and number, the total weight, the total number of attachment points that are going to be on the roof, weight per attachment point, the maximum spacing between the points on the rail, the total surface area of solar electric modules, how much space on that roof is it actually going to take up, how many square feet, and the distributed weight, so 2.53 pounds per square foot. We've got to have the amount, the quantity of inverters, the make and model of those inverters, and then also the PV modules themselves, the solar panels themselves, how many of that's going to be, the make and the model number. We require this information because when we go out to do the actual inspections, we match that with the information they've provided us. So if they have changed the model of solar panel that they're installing, which actually happens pretty often because the technology changes so rapidly that sometimes they sell a project, and when it's time to actually order the material, have it delivered and install it, those modules are no longer made. It's pretty incredible how quickly that turnover happens. So if this model number has changed, then they have to resubmit that information to us. So the next step of the process is the actual building permit application. Again, we've got to have all of the pertinent information, all of the contact information, what subcontractors they're going to use. Now, we require all solar installers in our jurisdiction to be licensed where we are. So they come into town. If they don't have a license, then they have to provide some documentation proving that they can be licensed with us. And unless they are a licensed electrical contractor with us, then they are not allowed to do any of the electrical work. We require all electrical work, whether it's for the solar installation itself, tying into a panel, tying into the meter. All of that can only be done by a licensed electrical contractor and certified journeyman or master electricians. So for this, they've got to have an electrical subcontractor. So type of improvement, obviously, we don't have solar as an option, so it's an other. It's a single family home that this is going on. Yes, it does have utility meters. It does have city water. Some things aren't really relevant on our building permit to solar installations, but they're still required to fill everything out. The valuation of the project. So this is where we come up with how much that building permit is going to cost. So this installation, according to the contractor, is going to cost $49,000 to put in. So one of the big things that we require, like I mentioned, we have an engineer. They have to provide a letter. It's got to have who the company is that they're providing this for, where the installation is going, and it has to meet all of our codes. So we are currently under the 2018 edition of the International Residential Code. And in our location, we're wind exposure category C, ground snow load, 15 PSF, 115 mile an hour gust wind speed. The existing roof structure, they have to explain how that's built and what the roofing material is and the slope. They also have to say how that's going to be mounted to the roof. So they actually have to confirm exactly how that's going to be installed on the roof. And so that when we go out to do our inspections, we verify that as well to make sure that they actually have used these products, the screws, and no more than 48 inches on center along the rails. Again, you can see that this was stamped by a local or a state certified engineer.
Hey, Dave, we got some questions if you want.
Yeah.
Okay, some built up here.
So what about if an owner is doing it? In our jurisdiction, we don't allow homeowners to do PV installations, just because of the nature of them, even if it's quote unquote off grid, right? A lot of people will say, well, I'm not tying into the service. There's still potential for death if you do it wrong, potential for fire. There's potential of grave injury if it's done wrong. So we require only licensed installers to do any kind of solar installations in our jurisdiction. I have seen an owner install their own PV array. I have yet to see one do it correctly. Doesn't mean they're not out there. Again, but that's why we don't allow homeowners to do their own PV array. Someone asked if Kansas subsidizes solar. Right now, no, Kansas does not. I think all the states around us do. Kansas doesn't. And to be honest with you, when as many PV arrays as we're seeing just in our county, if Kansas subsidized it, I think it would just triple and kind of cripple our inspection department, to be honest with you. We'd have to actually hire some new people to make that work. All right, so good questions. That answer everybody's questions right there on that? All right, I'm going to go ahead and kind of touch base a little bit on go through what we see when a set of plans is brought to us. So like I say, based on our requirements, they have to have a full set of plans. You'll notice that this set of plans is 15 pages long. We actually have to read every bit of this so that we know, that they're on board. Their plans have to state these things. The utility interconnection application must be approved and PV system inspected prior to parallel operation. Ground fault detection and interruption device is integrated with the microinverter. So probably not going to get too much into inverters, microinverters. There are some AC, there's some DC installations. A lot of the power coming off the solar panels is DC, and there are certain requirements based on those criteria. So, like I say, we read through all of these issues. Go through all of the notes that they have in here. So this drawing, it's in relation to how it's going to be installed. So street, driveway, garage, and this is where they're going to be installing the solar panels. And on this wall here is where everything's going to be, all the electrical is going to be installed. This is a good one. If you don't know, depending on the roof, how the access goes to the roof, there's a minimum of 3 feet of clearance that has to be left for firefighter access. So along the sides, along the ridge line, there has to be a 3-foot area for firefighters to access. If that's not there on the plan, it immediately gets kicked back. That's a big requirement. These letters in here indicate what array they're going to use. The A's are one model, the B's are another model. This one's talking about the roofing material. It's asphalt shingle, the flush mount solar modules, attached to the roof surface, and when we get to the page, it'll actually show the mounting details so that you can see how they're actually going to be mounted to the roof. This is the one-line drawing that I was mentioning. One of the things that our local utility, so we have 4 utilities that we deal with in our jurisdiction. The main one that we deal with, and they're the only ones out of the 4 that require this, they actually require what's called a production meter. So what that does is that tells them how much energy the solar panels are producing and potentially putting back on the grid. Even if it's not a system that's designed to go back on the grid, they still have that potential to go on the grid, and the local utility, they want to know what that potential is, how much power is coming back on the grid, so that in case they have an outage and they've got line crews out working on them, they'll know the potential of what might be there, and they can know where they are and go shut them off. So here, It's coming in from the utility, goes to the utility meter, comes down and hits the main panel, the load center, the breaker box. Over here, we've got the production meter. We have a 60 amp disconnect with 40 amp fuses. This is the communications gateway. This junction box, whether it's just a junction box or considered a combiner box. That usually tells us that there. And then these over here are the branches or the strings. PVs typically talked about in strings. So we have two different strings here for this particular one. Let's see, what do we got? Okay, so some counties in Florida with net metering require homeowners to shut down their systems during mass power outage. That's fantastic. We don't have that here yet. I think that eventually we'll get there. I think that there's some potential confusion though with that, because if a homeowner's not home and they have a huge power outage, let's say they're on vacation, there's still a chance for that power to be fed back to the grid. So, but that's good. Let's see. So the 3 foot are not required in Texas. So that's actually a national code. So Texas, unfortunately, kind of lives by their own rules sometimes. So if they're not requiring the 3 foot walkways, to me that's dangerous, but not a lot we can do about Texas, because they like I say, they do things their own way. A lot of things I really enjoy about Texas. That would scare me just a little bit. All right, so this just talks about the branch summary. So branch 1 will have an output power of 3,600 watts. Branch 2 will have an output power of 3,120 watts. I won't get too in depth here, but you can see here there's 28 of this model, and each one shows what they're capable of and what they're actually doing, what the disconnect is, what the inverters are, all of that. This one's a big one. So the codes require a lot of signage on solar installations. All of these stickers or placards are required to be installed on where the meter is, where the main disconnect is, where the rapid shutdown is installed. And especially if you have the arrays going to a disconnect on one part of the house, and the electrical meter and everything's on the other side of the house, we actually require not really a map, but signage saying where that is. So here's the page with the actual installation information, how the racking is going to be installed, how they go down, what it potentially should look like in those areas. This is the roof down here. You can see the lower left. This is the roof. This is the attachment point, and the rack is up here. Same thing with this one here. You can see how the attachment point is and how it attaches to that rack rail right there. Here's the spec sheet. This is the PV module that they're installing. Has all of the information that we require. This is the microinverter. It's got all of the information that tells us all of the electrical potential that we've got to deal with is on here. This is a combiner box. I wish it actually had an open picture of it. Essentially what a combiner box is, all of the string cabling from the arrays goes into this, and it ties into contact points inside that box. It's not just wire netted together inside that box like a lot of them end up getting. It's actually tied to contact points in there. I prefer combiner boxes as opposed to junction boxes, but junction boxes are allowed. So the shutdown, rapid shutdown system equipment. So depending on where you are in the country and what code you're under, the system has to shut down in a certain amount of time, whether it is 30 seconds or 60 seconds. It just depends on what code you're on. I think we now, with the latest code that we're under, the shutdown can actually take up to 90 seconds to shut down, and that's all power coming from the arrays to any distribution equipment. So some more information on the rails, actually what they are and how they're going to be installed. So these installation points right there, they're fairly new. Previous to these installation feet like this, the rails had to actually be attached to the trusses underneath the roof. These feet right here actually are designed, and if installed correctly, can just go through the plywood sheeting of the roof, and they actually work fantastically. I was surprised the first time I saw one. I didn't think that it would be as good as they are, but they actually work really, really well. All right, that's it on that. Before we just get to maybe a couple of extra questions, if you guys have them, I'm going to show a couple of, I've only got a couple of pictures of some installations here in town. So this is show up on a job. We require 2 inspections. We require what's considered a rough end inspection and then a final inspection. So on the rough inspection, what we're looking for specifically is the rails, their attachment points. We are looking for, and I'll have a picture in a minute that shows it better. So in this junction box here, all the wires already pulled in. The conductors have to be solar rated conductors. Can't just use, unfortunately, it's kind of crazy, can't just use THHN on solar installations. So we check the wiring, make sure everything's grounded and bonded correctly, make sure the rails are clipped on and installed per the manufacturer's instructions. And each of the attachment points are installed correctly. We actually even get it into the attic and verify if they're coming through the sheathing, that they're coming all the way through like they're required to. It's not just going down through the asphalt shingles and just barely into the sheathing. It's got to go all the way through the sheathing. Here's another one. This one's, my opinion, a little nicer. You can see the bonding wire here. So this is a bonding wire that bonds those racks together, which bonds the arrays, all the arrays together. Now you'll notice it doesn't go to all 4 rails. If you're bonding here and using the correct attachment points or the attachment clips in the for the PV arrays, for the panels themselves, everything will then be bonded together. This is a junction box, but it's like say everything's just wire netted together. You can see here they've actually installed a ground bar. There's enough ground wires in that we require a ground bar. We don't allow all of those just to be twisted together or wire netted together. We want them under a bar, tightened down, torqued down, so that we know they're going to get a good connection. We're not going to lose a bond or a ground. Here's a little better picture of that bonding. So it comes out of the box, comes down here, and it bonds to this rail. And it goes down and bonds at this rail. Open splices like this are permitted on solar systems. This is DC wire, and this open splice is permitted. You don't usually see open splices on wiring these days, but that is permitted. Rob, yeah, so should mounts be near a truss or anywhere in the sheathing? Depends on the mounts that you're using. The manufacturer's instructions will dictate how they can be installed, whether that has to be on the truss or joist, or it can be anywhere in the sheathing. Like say, just in the last, I think the foot that I was talking about earlier came out less than a year ago is when we started seeing them that could be mounted anywhere on the roof. So it depends on the product that you're installing, how it's got to be installed. And as AHJ, we do have codes that we follow, but if a UL listed product can be installed properly, differently than what our codes say, we will actually 9 times out of 10 go with the product manufacturer's instructions on how to install it. All right, so this is just another one of those boxes. You can see just a little clearer. It's a little better picture. These are the array wires. They're array cabling that tie together. It's just a combiner box that brings all of that wiring together. Let's see, does an engineer have to sign off on ground-based arrays? Actually, yes. In our jurisdiction, they do. A ground-based array still has to handle the load of what's installed on it. So it's got to handle the PV modules, and it's also got to handle the snow load and the wind shear. So we do require an engineer to sign off on even ground-based arrays. You know, and actually that brings up a whole other issue. So ground-based arrays are a totally different animal. They follow a lot of the same rules, but their installation can be totally different, and the requirements for protection from touching any of the components on the backside, whether that's we've seen on the back sides of the panels, the protection that way. We've seen just fencing that keeps people out of it. There's so many things that can be dangerous to people. Okay, so if you do an inspection and find other code violations not related to the permit, do you call them out? You know, Doug, that's a great question. Probably the real answer is it depends. If there are violations that I see, electrical violations that I see that aren't life safety, I'll probably just bring it up to them and say, hey, you want to get this looked at. If it's a life safety item, something that I would consider life safety, an open splice that a kid could grab a hold of or something like that, then yeah, I'll probably call it out. I won't give them their I wouldn't sign off their inspection until all of those things are complete. So I've got some other pictures that I was hoping to show, but I need to can't seem to find them for some reason. I don't know what happened. It's not it. See if I can find. And unfortunately, I don't know where those ended up. I did have more pictures of things actually on the sides. Okay, so another J asked, do the shingles or roof covering need to have a minimum life expectancy before a system can be installed? Honestly, we don't look at that. Typically, an engineer, if they're truly going out and looking at it like they're supposed to before they issue the letter that it's okay to install the panels on the roof, they're going to address that. If they don't address that, then there's not a lot we're going to be able to do with it. I'm open to any other questions you guys got if you want to keep shooting them at me. Anything? Well, let's see, does this significantly raise the cost of getting new covering? It could. Uh, having a solar array on a roof could significantly raise the cost of it because now they've got to remove the panels, the racking, and then reinstall that. So it's a great question. I think I would say if you've only got 5 years left on your roof and you put a solar array on there and everything starts leaking, then it probably would be an issue. Can a regular roofing company do that work? Not in our jurisdiction. They'll have to hire someone to remove the panels and racking and reinstall. So yeah, so it could definitely be an issue at that point. Great question. Who? We as home inspectors, how much is the ballpark figure to charge for a PV inspection? Dan, it's honestly on the home inspection side of it, it's a little bit out of what we're required to do. I don't think it will necessarily add a ton of time to an inspection. When I go to a house as a home inspector, I have to take my code enforcement hat off, put my home inspector hat on. If I'm going to a house that has a PV array on it, I'm going to make sure it's bonded. I'm going to make sure there's no open junction boxes, there's no nicks or cuts or abrasions in the wire. So if this cable right here, this little cable right here starts getting abrasions on it, it's going to quickly deteriorate that outer jacket and it's going to create an issue. So I look at that. I look for those things. I make sure that there's nothing touching the roof. So no wiring, none of the PV cabling, none of that can touch the roof. Now, if they have conduit going across the roof and down to a combiner box or where all of the electrical is, then that can be on the roof and attached to the roof. But an open cable, that needs to be off the roof. Aren't these boxes covered by the paneling? Aaron, I'm not sure exactly what you're asking. If you're asking if it's just if they're protected by the panel, maybe, but for a safe installation, this box has to have its cover installed before the PV panel can be installed on top of it. I like these questions. These are great. Keep coming at me. Because I have completely lost. Yeah, so Eric put on there, look up Soladeck. Yeah, so every junction box or combiner box is required to have, they're required to have covers on them to be code compliant. So Jan, thermal drone camera inspection. I have never done a thermal inspection on PV arrays. I have heard if you know what you're doing, they're a great inspection tool that you can potentially find damaged arrays. I personally have never done that. I think if you're doing drone inspection, roof inspections, you're still going to look for the same things. Obviously, you're not going to be able to, if you're not getting on the roof, which we're not required to, you're not going to grab things. You're not going to be making sure everything's stable and tight. But a drone will tell you then if anything looks out of the ordinary or has some issues. For inspection purposes, wouldn't these be hidden by paneling, meaning we wouldn't be able to see these? Okay, Aaron, yes and no. There's going to be a gap between, I really wish I could find the pictures that I had. Let's see, because I had a couple of really good pictures that I could show you that kind of shows what you would see. And I apologize for not having those ready. Not to use it as an excuse, but I battling a little bit of COVID symptoms today, so obviously I was not 100% with my preparation this afternoon, and I apologize for that. Yeah, I just do not have those pictures available right now, and I apologize. As far as the electrical flow from the array to the panel, let me try and open. Okay, so Rob, when doing a regular home inspection on a one-story home, I like to go on foot. Should I give the panels a wiggle? I do. I make sure they're attached firmly to the rails and that the rails are attached firmly to the roof. Obviously, I check the flashing for these boxes and eyeball the wiring. What else should be inspected? That's really kind of it. You might take a look at any penetrations going in the roof. So if we go back to this, you can see right here in the center of this box, that's actually penetrated through the roof. Our goal would be, if we can't see the actual penetration, if it's flat down on the roof, we're going to want to see all the way around the box having some kind of sealant, whether it's silicone, caulking, some things like that. So as far as the flow of the electrical, so Doug asked if we could step you through the electrical flow from the array to the service panel. So over here on the left, we've got the PV panels, the arrays. They're going to go through to this combiner box, and this particular combiner box has breakers in it. So the power is going to come to these, and that's going to flow through these conductors into this disconnect. From the disconnect into the meter, the production meter, if it's required. Like say our local utility, one of the 4 requires it, the other 3 don't. Then it comes through in here, and inside the panel, the load center, the breaker box, it'll be attached one of 2 ways. If it's coming into the breaker box, it will be attached either onto a breaker that's correct size for the arrays, or it will be tapped directly onto the service conductors coming from the meter into the panel. So what happens is, for this to work, this combiner box, this is where all the magic happens. So the combiner box converts everything from DC to AC that allows it to go back onto the grid or into the panel. It also, if these are not producing voltage, it's got voltage coming into it. It has to sense the voltage coming into that inverter. Otherwise, it will not allow the power to come back out of it, if that makes sense. It's kind of working both ways. It has to see utility power coming to the inverter for it to work. Again, here in the combiner box, the inverter, this actually is where it turns the DC to AC and flows it back this way. Does that answer your question, Doug? Preston asked if we re-inspect if a roof is replaced. At this point, that gets a little, I don't want to say sketchy with us, because roof inspections have been an issue for us. We finally got a full-time inspector that all he does is roof inspections. He is supposed to contact us if there's a roof that he is going to inspect with a solar array on it. To my knowledge, we haven't gotten that call from him yet. In theory, yes, we have to go back and re-inspect that, but sometimes that falls under the, if we don't catch them, we don't know about it kind of thing, unfortunately. Does the AHJ require a certain voltage system? We don't require a certain voltage system. That's typically dictated by the manufacturer of the arrays. We don't have a specific voltage that we require. All right, everybody. I really appreciate everybody being here, and you guys have asked some great questions. I really appreciate everything you guys have asked. I want to thank you all for joining. And if you have any more questions, I'm sure you can reach out to the guys at InterNACHI, and they can forward any questions along to me. Thank you guys. Thanks everyone.